going to look at the force plate data, which is if you go to your summative assignment page and then to the data for summative assignment link on that page, click on the force plate data and it will download the zip file folder for you, which you can then take the data and extract it to wherever you want to put it. So I'm going to select extract and I'm going to place my data onto the desktop. You can place it wherever you want as long as you know where it is. So select the folder, desktop, click OK and extract the data. So I'm going to go to my desktop now and I should be able to see the force plate data folder. There it is. So click on that and if I click on a file it will come and open up in Notepad or WordPad, which isn't what we want. We want to be able to use this data in Excel. So what we need to do to be able to open in Excel is actually go into Excel and effectively pull the data into Excel, not actually open the data by double clicking on it. Let's get rid of the notepad. Let's open up Microsoft Excel. I'm just going to make it a bit smaller so it's going to fit both on the screen. And all I need to do is drag and drop the files in from the folder they're in into Excel. Nice and easy way of doing it. And Excel is pretty good at recognizing it now. And you can see we've got some force data. Okay, so now we've got the force data. We need to have a bit of a look at what we've actually got to deal with. Now, you can see the name of the file, LO1, GO1, STO1. Well, that means lab 1, group 1 within that lab, and it's the height of the sternum and number 1 lift. If you just look at the top, the file name will be there. So we've got this force data. Well, we've been kind to you. When we downloaded the data, we only have 2 columns worth of data. On the left, you have the time. And on the right column, column B, we have the force data, which if you look in row 12, FZ, so force in the Z direction, the vertical, and it's of course measured in newtons. So let's have a look at this data. So if we click on the top of the row, hold down Shift and Control key and press down, it will highlight all of the data within that column. So let's do that, hold down Shift and Control, press down. Now we've highlighted all that data, we can do something with it. We're going to insert a line graph. If you ever want to look at data and see what's going on, graphs are always the best way, as you've learned from your labs. So insert, and then we'll select a line graph, and any of the line graphs really will do. There we go. Okay, so now we have this data. There's a few things we can do. We can look at what's happened when they've been collecting the data, and also is it reasonable? Well, as you can see, it starts off at over 800 newtons, which suggests that they zeroed the force plate when the person was stood off the force plate, and then they've stepped onto the force plate, which is fine, but we just need to make sure we're aware of that so we don't consider their muscular force to be too much, because obviously their peak is up to, say, 1550 newtons approximately, but that's including their body weight. So we really need to take a baseline and take that away from that force data, from the peak data, or else people who are heavier will appear to have producing more force than those that are lighter, and it wouldn't be a fair test. So we need to baseline that where it's necessary, which will be in most cases. Even if they have zeroed it, there may be 10 or 15 newtons either way out, so it's worth doing each time. So we're going to look at doing that now. So we need to check, find out what we're going to consider our baseline. So to find the baseline, we need to come up with a method of doing so that's repeatable. Now, one nice method is if we look at, say, the first value. Well, the first value says 827.7 newtons, so we could take that as a baseline. But if you look within that data, there's a bit of oscillation, there's a bit of data going up and down there, so it's not consistently 827 newtons. So what we may want to do is take a mean over a certain period of time. It could be from the start to the bottom of the slope, so where the squat starts. It could be over a second, depending on whether we've got a second's worth of data beforehand. It's up to you. Ideally, see what's been done in the literature and what you can take from that to apply to your data. I'm just going to take a random amount today, so I'll look at over the first, say, 20 or 30 frames today, and I'm going to take an average of those 20 to 30 frames. So to do that, go to the top. To do that, I'm going to just click on a random cell nearby, and I'm going to calculate an average. So let's just select this cell. You may want to give it a title so you know what it is you've calculated, and we're going to find the average from 20 or 30 cells. So like we did with the maximum, if you can remember the name of the code for it, for the function, it's just average, so you could type in equals average, or if we click the function button above, we can select the function to use. So we click the function button, the FX button, the insert function window will open, and we can choose what it is we want to look at. Well, we want the average this time. If you read below the average, it says it returns the average arithmetic mean. So average in Excel means it's the mean, so it's not the mode or the modal. So we click OK. The next thing we need to do is identify 20 or 30 cells. So I've got about 35 cells there, and click OK. So we've taken average from about 35, 36 cells, and it's 825.8 newtons. So you could round that to the nearest newton if you wanted to. The accuracy of the force plates movement means that you're quite happy to go to the nearest newton. So the baseline is about 826 newtons. So now we have the baseline value, we can try and find the maximum, and we're considering the baseline value as well after that. So to find the maximum, the same way as we've done in other previous data, if you've not done it before, it's the same way as we just found the average. So if you click, I'm just going to insert a row there to make it nice and tidy and put the maximum value on the top. It's up to you again how you lay this out and how you do this, but you'll develop your own preferences on layout. So I'm going to click a function button, and I'm going to use the maximum function. Click OK, and I'm going to select the data by clicking at the top cell, holding down Shift and Control and pressing down. As you can see, I've highlighted all the data now. Press enter, and I now have a maximum value of around about 15,000 newtons, I think it is. Sorry, 1500 newtons, obviously. So we've got 1500 newtons, 1559 newtons, maximum value, but we know that there's the baseline, so the body weight is included in that. So we need to actually take away the body weight. So we've got the body weight, our baseline, located in the cell D13. So we need to take that away from cell B14. So let's do that. B14 minus D13 gives us the actual force applied, the muscular force applied to the force plate during the isometric squat. You could do that a number of ways, but that way you keep it in Excel. You haven't had to note down the data. More likely to be accurate. So that'd be the method I would use. So we've calculated a peak value now, but we may want to look at other variables such as the rate of force development. Now to do this, we really need to look at the graph we made earlier, or if you need to make a graph, highlight the data, make a line graph. And you can see it's tricky to identify where the peak starts. A lot of, if you're looking at rate of force development and various other variables, you'll need to know when you actually consider the squat to start. So if you look at the graph, it's a bit tricky to identify that. You can see it starts to increase sort of slowly and then shoots up. So if I highlight over the graph, you may consider it to start there. But if we move it along even slightly, you can move along 100 points and it won't have increased very much. So actually identifying when the squat starts is problematic, because if you're out by 50 milliseconds, it can have a huge impact on the rate of force development when you're looking over especially short periods of time like 100 milliseconds. So ideally what we need to do is come up with a way where it takes out subjective interpretation of the graph. We need to come up with a way that is going to be the same for whoever does it, making it replicable, which is vital within scientific research. One such way is we could look at where we look for an increase in the force of 50 newtons over the baseline. So let's go and remind ourselves what our baseline reading was. Well, the baseline turned out to be 825.8 newtons, so about 826 newtons. So we need to add 50 newtons to that if we're going to apply the rule that the squat starts when it goes to 50 newtons above the baseline. So 825 becomes 875, or to round it up, 876 newtons. So we need to scroll down and find where the force goes over 876 newtons. So going down a little bit more, I've gone past it there. Okay, there we go, brilliant. So it's gone above 876 newtons. So we can consider that to be the starting point. So we've got a time of 0.293 seconds and a force value of 876 newtons. Now you could take the baseline off that if you wanted to. You could take it off every value. It depends what it is you're looking for. When we're looking at the rate of development of force, it doesn't matter where we start at, because we're looking at from the starting point to the end point. So it doesn't matter if we start at 0 or 900, because it's the increase from this point to another point in time that we're really interested in. So now we've found that, we can copy and paste that data and try and use it to work out the rate of force development. Okay, so now we've copied the data, let's paste it and put it up here. So now we've got the starting time of 0.293 and the starting force of 876 newtons. So that's where we're going to start to calculate the rate of force development. Now the rate of force development can be calculated over various periods of time. Just as an example, we're going to look at it over, say, 200 milliseconds or 0.2 seconds, but it can be over anything as long as you've backed it up. So if we add 0.2 to it, so take that time in G2, add 0.2, enter. So this is the new time. So it's going to go from 0.293 seconds to 0.493 seconds. So the next thing we need to do is go and find 0.493 seconds in the data to find what the force value has increased to there. So find 0.493. There we go, it's gone up to 1,225.9 newtons. Let's copy and paste that up to the top. Okay, now we have the start and finish times, 0.2 apart. We also have the start and finish forces, so we can see how much the force has increased. So now we can do the calculations to calculate rate of force development. Remembering that rate of force development is the change in force divided by the change in time. So the change in time is 0.2, the change in force would be 1,225 minus 876, so how much the force increased. We could do that in a calculator, but let's do it in Excel. So increase in force 1225, so H3 minus H2, so the force has increased by 349.7 newtons. Now we can calculate the rate of force development. So if the change in force is 349.7 newtons, that change took place over 0.2 seconds. So we can divide the increase in the force, so in I2, by the change in time, 0.2 seconds. Or we could do G3 minus G2. But we know it's 0.2, so let's make it easy on ourselves. So if we press enter, we've now calculated the rate of force development. So you now have the clear variables that you can use to analyse the performance for your research questions. Good luck.